In the previous lecture, we had a very basic understanding about framing, and in today's session, we will formally see what is framing. We will start the session with the outcomes. In today's session, we have 3 outcomes. We will see what are they one by one. Upon the completion of the session, the learner will be able to: outcome number 1, understand the basics of framing formally. Outcome number 2, understand the types of framing. And the last outcome, we will know various framing approaches. We will start the session with what is framing. We know framing is one of the services of the data link layer. And if we say there are 2 nodes, and these 2 nodes will obviously have adapters. And when we talk about nodes, frames are going to be exchanged. When we talk about adapters, the bits or the signals are going to be exchanged. Framing in the data link layer separates a frame distinguishable from another frame. Suppose if node A wants to send a bulk of information to node B, and this cannot be sent as a single frame, so node A creates 10 frames, for example. And all these 10 frames are going to be placed on the medium, and we expect the receiver to understand that there are 10 frames. The receiver's adapter receives the continuous zeros and ones. It becomes the responsibility of the receiver node to exactly construct the frame as like it was sent. So framing in the data link layer separates a frame distinguishable from another frame. And we know that frame means it is the network layer PDU that is additionally added with the header and the trailer of the data link layer. We will see what is the role of framing in packet switched networks. In packet switched networks, the block of data called frames are exchanged between nodes, not the bit streams. We have already seen this point. Between adapters, we see that there are bit streams. But actually between nodes, we say that there are frames that are going to be exchanged. We will also see the other aspects. Suppose when node A wants to send some data to node B, what it actually does. When node A wishes to transmit a frame to node B, it tells its adapter, that is, node A tells its adapter, this adapter, to transmit a frame from the node's memory. So the data that is received by the data link layer is ready and it is created as a frame. And it tells the adapter to place, or it tells the adapter to transmit a frame from the node's memory. So this results in a sequence of bits being sent over the link. So the sequence of bits are going to be sent over the link, and it is the responsibility of the adapter to send the sequence of bits over the link. After node A sends the data, now it's the turn of node B to deal with it. The adapter on node B then collects together the sequence of bits arriving on the link and deposits the corresponding frame in B's memory. So we know A has sent the continuous sequence of bits, and the B's adapter will receive all the sequence of bits and it stores the sequence of bits as frames in B's memory. We have a big challenge in front of us. The challenge is what sets of bits constitute a frame. It is easy for both the nodes if the frame size is fixed, because if we say 10 is the frame size, whenever it receives 10 bits, it can construct a frame and place it in the memory. Again, if it receives another set of 10 bits, it creates a frame and stores in the memory. If the frame size is fixed, it is easy. What about if the frame size is a variable size? And that is what we are going to see, the types of framing. We have basically 2 types of framing. One is fixed size framing. Number 2, variable size framing. We will see one by one. We will start with the fixed size framing. In a fixed size framing, the sender and receiver know the size of the frame. So it is easy for the sender and receiver to construct the frame. Here, the size of the frame is fixed so that the frame length acts as the delimiter of the frame. For example, if the size is 100. After receiving 100 bits, the receiver can understand that frame 1 is collected. Then the next set of 100 bits means it is frame 2. Consequently, it doesn't require additional boundary bits to identify the start and end of the frame. Since the size itself is acting as the delimiter, it does not require any additional boundary, or it does not require to give a start of the frame or the end of the frame. There are variable size framing also. In a variable size framing, here the size of each frame to be transmitted may be different. For example, 100 bits may constitute frame number 1, 60 bits may constitute frame number 2, 80 bits may constitute frame number 3. But in this case, it's very difficult because the length is not uniform for all the frames. The size is not uniform for all the frames. So it is a must to maintain the start of the frame and the end of the frame. I hope you guys can recapture what we have seen in the previous lecture. We had seen in the previous lecture that the start of the frame and the end of the frame that helps the receiver to construct the frame. So additional mechanisms are kept to mark the end of one frame and the beginning of the next frame. So in a fixed size framing, we need not maintain any such start of the frame or end of the frame, whereas in variable size framing, we are required to maintain the end of the frame and the starting or the beginning of the frame. And this will help us to construct the frames without framing errors. And that's it about the types of framing. So far we have seen what are the basics behind the framing and the types of framing. Let's have a look at the various framing approaches. When we talk about framing, we have basically two approaches. One, it is bit-oriented approach, and number two, it is byte-oriented approach. Byte-oriented approach are also called as character-oriented approach. We will talk about this elaborately in the upcoming lectures. And that's it, guys. I hope now you are clear with the basics of framing. You understand the types of framing. We have two types of framing. One is fixed size framing, another one is variable size framing. And we know the various framing approaches. It is bit-oriented approach and byte-oriented approach. I hope you guys have learned something new in today's lecture. I hope the session is informative, and thank you for watching.